For decades, industrial automation has felt, well, pretty stuck. We've had all this incredibly powerful hardware, but it's been trapped, just shackled by really rigid, super complex software. So today, we're going to dive into a fundamental shift that's changing the factory floor forever: the move to a universal operating layer for industrial AI.
Okay, so let's start with a problem that pretty much every manufacturer knows all too well. You go out, you invest in state-of-the-art robots, and then you hit a wall. And it's almost never a hardware problem, right? It's a software and integration bottleneck that has been slowing down innovation for years.
And this comparison just lays it all out perfectly. On the one side, you have the old way, the legacy approach. You're locked into one vendor, you're writing thousands of lines of code for just one task, and it's completely inflexible. But on the other side, well, that's the promise of adaptive AI. It's hardware agnostic, it's dynamic, and it lets you build logic without needing a whole team of specialist coders. Man, this quote really gets to the heart of the frustration, doesn't it? Your traditional robots, they're amazing at execution, but only in a perfect, totally unchanging world. The second something is just a little bit off, a part shifts, a bin gets moved, the entire line can just grind to a halt. Why? Because the system can't problem solve. It can only execute. So here's the bottom line. The siloed model is the bottleneck. Every single robot speaks its own weird proprietary language. A task that seems simple can take hundreds of engineering hours to program, and you basically need a small army of specialists just to keep the whole thing running. This has made real, flexible automation totally inaccessible for almost everyone.
But what if you could build a new foundation right on top of all that existing complexity? This is exactly where the Universal Operating Layer for Industrial Robotics, or UOLIR, comes into play. Think of platforms like FlowState. They're creating a brand new, intelligent foundation for the factory of the future.
To put it simply, a UOLIR is a software layer that basically acts as a universal translator. It completely separates the what you want to do from the nitty-gritty how the robot actually does it. And that is the key that unlocks adaptive intelligence, letting a robot finally think, not just execute.
Oh, I love this analogy. It is just perfect. For so many years, programming a robot was like writing an assembly code. It was incredibly difficult, it was specific to one single machine, and it was painfully low level. This new layer, it's the operating system. It's the Windows or the Mac OS that manages all of that insane complexity for you. So the big question is, how does this operating system actually work? How does it take a simple goal, like pick that up, and translate it into precise physical motion, no matter what kind of robot it's controlling? Let's break down the architecture. This gives us a great bird's-eye view of the UOLIR architecture. At its heart, this platform is a 3-layer stack, and it's designed specifically to abstract away all that hardware complexity we've been talking about. It all starts with the user's high-level goal at the top, passes it to a smart engine in the middle, and then finally translates it into commands that a specific robot can actually understand at the bottom. Okay, let's walk through this layer by layer. It all begins with the northbound interface. This is the simple part. It's where a user defines the what using easy no-code logic, like just dragging a grass block. Then the translation engine, the brain of the operation, takes that simple goal and figures out the really complex how. And finally, you've got the southbound interface, which acts as the driver, speaking the robot's specific native language to get the job done. So the real magic, it happens right here in the translation engine. This is the absolute core of the entire operation. It takes a simple command that we can all understand, like pick up object, and maps it to a standardized internal model. Think of it like a universal blueprint for action that can be adapted for literally any robot, no matter the brand or the type.
And inside this brain, there are two absolutely critical components. First, the kinematic solver. This is the mathematician of the group. It calculates the exact joint angles needed for that specific robot's arm to reach a target. Then you have the state machine. This is the safety supervisor. It is constantly monitoring the robot's status to prevent errors, like trying to grasp an object when the gripper is already closed.
And here's where the rubber meets the road, the technical proof of its power. This system can speak completely different robotic languages. On one hand, it can talk with something like ROS2, which is awesome for complex AI and uses this flexible message passing system. The platform just standardizes these into simple JSON packets. But then, on the other hand, it can control a super high-speed motor using EtherCAT,
which needs rigid, deterministic commands. For that, the system uses a real-time kernel to generate these incredibly precise, steady position frames. The point is, the operating layer just adapts its communication style. It's the perfect translator for whatever the hardware needs.
Okay, so we've covered the operating system. But what about the AI part of industrial AI? Well, that really comes down to three key pillars that turn a simple machine into a truly adaptive partner: perception, reasoning, and learning.
First up is perception. This is all about how the robot becomes aware of its environment. And we're not just talking about a camera here. It's the fusion of computer vision and sensors that allows the machine to genuinely see and feel its workspace, so it can detect and track objects in real time. Next, we have reasoning, and this is where the intelligence really starts to shine. By using things like LLMs and neural networks, the robot can now actually think. It can take a big, complex goal, break it down into smaller steps, and, this is the most important part, it can replan its approach on the fly if it hits a snag. It stops just executing and starts solving. And finally, there's continuous learning. This is what really future-proofs the whole system. Through reinforcement learning, the robot gets better at its job with every single cycle. It's refining its own skills and optimizing its performance all by itself, without a human having to jump in and manually reprogram anything.
So, when you put it all together, this universal operating layer and this powerful AI ecosystem, what does it actually mean for a business? Well, the impact is nothing short of a total strategic shift. You're moving from simple execution to genuine intelligence.
And let's be really clear here. This is not some science fair project. We are talking about industrial-grade software that's built for the factory floor. It has the real-time performance, the safety constraints, and the hardcore reliability that production lines absolutely demand. Now, a massive piece of that reliability comes from the digital twin. This system runs a perfect physics-based simulation of the robot right alongside the real thing. And this isn't just for a cool visualization, it's a core safety and performance feature.
This is so important. Before that physical robot arm even twitches an inch, its planned movement has already been run through the digital twin. That simulation can predict collisions and guarantee safety before an accident ever even has a chance of happening.
And this just brilliantly illustrates the change in mindset. Before, your best engineer had to sit there and ask, okay, how do I program these specific motor movements? But now, anyone on the team can ask, how do we achieve this business goal? You're not programming motion anymore, you're defining outcomes.
And the ultimate payoff here is agility. The ability to retask a robot or change an entire production line or adapt to a new product, that's no longer a 6-month engineering nightmare. It's something that can be done in a matter of days. And that gives manufacturers an absolutely incredible competitive advantage.
And all of this leaves us with one final, and I think pretty provocative question for you to consider. In an era where everything is constantly changing, is your factory built just to follow a rigid set of instructions, or is it equipped with the intelligence to truly solve problems as they happen?